All right, I'm going to go through the Jeopardy questions. I may not go through all of these because some of these I went over in class with you guys. So if you need help, just send me a message or look at your notes, Google as well. So for this one, draw an example of two triangles that would use reflexive properties to show that sides are congruent. So the key word is here, I'm saying reflexive property for sides. So let me just go ahead and draw this. And then if we drew this line down here, this would be an example that two triangles are using a side. This would be our reflexive property because it's part of both triangles. Right, so, and your answers doesn't have to be exactly like this. Draw an example of two triangles that would use reflexive property to show that two angles are congruent. Well, here, if I draw a triangle and then another triangle within it, this is reflexive property because they both have this top angle. Another one that we've done is here both triangles, this red triangle and this green triangle, both have this upper angle. So this angle is reflexive in both triangles. All right, for this one, we're going to fill in the blanks. So all this was given to us. So our first reasoning is given. And then it says GFH. So GFH is congruent to IFH. So this angle is congruent to this angle. And why were we allowed to say that? Because it told us it bisects angle GFI. So it's definition of angle bisector. Reflexive properties here, well, I know reflexive property is the same thing as equal to itself. And here I have reflexive property because FH is part of both triangles. So we would have FH is congruent to FH. And then for here, our last statement is whatever we're trying to prove. So triangle GFH is congruent to triangle IFH. And our reasoning for this, we also knew that I and G were congruent, and this would be angle, angle, side. All right, so for this one, we're going to make our statement and reasons. So statements and reasons. The first thing we always write is whatever is given. So I is the midpoint of CM, and I is the midpoint of BL, and this is given to us. Then I'm going to go ahead and start filling this in. Well, if it's the midpoint, I know that these are equal, and I know that these are equal. I know that these two angles have to be equal because vertical angles, so I know that they're going to be congruent through side, angle, side. And then I can say that the two sides are congruent because they're in the same position. So our second thing that we're going to say is that CI is congruent to IM, and LI is congruent to IB. And our reasoning is definition of midpoint. For number 3, I can say angle 1 is congruent to angle 2 because they numbered it for us. And this is vertical angles theorem. And now we have enough to say that the two triangles are congruent. So triangle LCI is congruent to triangle BIM. And our reasoning for this was side, angle, side. That's what we wrote in the beginning. And now we look and see is CL, the first two, in the same, LCI, I'm sorry, it would have to be BMI, not BIM. This is why it's good to check your work, but BMI. And then we see that LC and MB are in the same spot. So CL is congruent to MB, and our reasoning is CPCTC. All right, so the next one is, are they similar? If so, write a similarity statement. Well, here I see that I have two pairs of angles, so we would say angle, angle. And then it's triangle GFH is similar to triangle. I went from 3 arc marks to none, so CBD. All right. Next one here, 48 is the smaller side, and so is 6. So I will then do 6 over 48, which is going to give me 1 over 8. All right, and then I will look at the larger one, 56 and 7, and 7 over 56 be consistent with which triangles on top. That also reduces to 1 over 8. I know that these angles are the same because they're vertical, so through side, angle, side, they are similar. So triangle KLJ is similar to triangle. I went through none, through the longest, so through none, through the longest, so GFJ. All right, are they similar? This answer is no, because we see here these are the same and these aren't. So it's no way that the ratios are going to be the same. From here, we will make the ratios. So we have 40 is the smallest, which corresponds to 64. So 40 over 64, they're both divisible by 8. So it's 5 over 8. The next one we have is the middle, so 45 over 72. These are both divisible by 9, so it's also 5 over 8. And then the last one we have is 55 and 88. These are both divisible by 11, so it is also going to be 5 over 8. So yes, through side, side, side. And then our similarity statement, triangle GFH is similar. So I went through the longest, through the middle. So through the longest, through the middle. So it'd be BAC. So triangle BAC. All right, so for this one, the one where a lot of people messed up with is we need to talk about this whole triangle as a side. So this whole side is 27. So when we create our ratios of 18 over 27, which reduces to 2 over 3, and then if this is 10 and this is 30, that means this has to be 20. And then we would do 20 over 30, which is also 2 over 3. And then we have the angle that they share, so it's side angle side. And then it's triangle SGF is similar to triangle SQR. All right, state if they're congruent. We don't have to do a congruency statement for this. So in this case, they share this side. So yes, side, side, side. Here they share this side, but the angle's not included between them. So this one is NEI, right? We cannot say that they're congruent because this angle is not between. If we wanted to say SAS, then the angle would have to have been here and here for us in order to say SAS. All right, then the next one. Are they congruent? If this is a right angle, so is this one. And since we have right angles in both these cases, we have our hypotenuse and the leg, so it is HL. Here we have this angle is congruent to this angle, so it will be angle, angle, side. All right, for here, we know that triangle ABC and triangle DEF are congruent. So ABC and DEF. All right, I know that A is 78, and I know that F is 55, and I know we're saying solve for the measure of angle E. All right, well, E and B are in the same position, so they correspond. So E and B are equal and congruent. Well, we don't know what B is, but if we know F and C are in the same spot, so I know C, that's also 55 degrees. So now I can solve for B. 78 plus 55 is going to be 133. I know a triangle adds up to 180, so 180 minus 133 is equal to 47 degrees. So if this is 47 degrees, so is E. So the measure of angle E is equal to 47 degrees. All right, for this one, make sure you're reading your similarity statement. X is part of XY. That's the first two, so that means it's equal to TU. So it's equal to this one. So 4x minus 3 is equal to 25. A lot of people are just looking and saying, well, it's on the left-hand side, so it must be equal to 13. That is not correct. We add the 3 to both sides, so 4x is equal to 28. Divide by 4, divide by 4. X is then equal to 7. All right, same thing for this one. Read your similarity statement. M is first. It corresponds with Q. So that means these two are actually equal to each other. So we would say 10x is equal to 70. Divide by 10. X is then equal to 7. And then from here, N corresponds with R. Well, we don't know what R is, but since we know these two angles, we can solve for R. We can say 70 plus 60, that's equal to 130. 180 minus 130 is 50. So that means this is 50, which means this also has to be equal to 50. So I can then say 5y plus 10 is equal to 50. Subtract the 10. 5y is equal to 40. Divide by 5. Y is then equal to 8. So we have x is equal to 7 and y is equal to 8.